have a little music for you guys. Somewhere Over the Rainbow. And this is for Tessa, who talks about this graph being a rainbow. So hopefully in your mind, you have an idea of what graph we're going to be working on today. Now, let's hop up and look at that graph. Okay, what graph am I talking about when I talk about Somewhere Over the Rainbow? I'm talking about this graph, aren't I? The square root function, or the radical function, which we've been studying. So this is the square root function's parent graph. The square root of x equals y. That is the square root function. Now, its beginning or origin is at 0. So when we talk about the domain on this one, we're starting at 0. Notice there's nothing to the left of this graph. We start at 0 and it goes to the right. So if we were describing the domain of this parent graph, we would say all x's greater than or equal to 0. We can also write that, that's the inequality notation. We can also write it as set notation from 0 to infinity, because it never stops. Okay, so that's the domain of this graph, beginning where x is 0. Now let's talk about the range of this graph. Up and down the y-axis, where does this parent graph start? Nothing down here, but it starts at 0. The graph starts at 0 and it goes up forever. So the range, that's the domain, the range of this graph would be all the y's greater than or equal to 0, because 0, 0 is part of that range. And finally, we can write that in set notation as from 0 to infinity, 0 including 0, so we use the squared off bracket, to infinity. So there's the domain and range of our parent graph for the square root of x. Now, remember, it's the inverse of an x squared function. And remember, we talked about that, what, Wednesday? If we find the inverse of that, we switch our x's and y's, and we take the square root of both sides, and voila, y equals the square root of x, and they're inverses of each other. So this part of the graph is really just half a parabola just reflected over, okay? It's half of the parabola reflected over. Now, you guys have heard me talk about A, H, and K until you are probably red in the face, but we're not going to say red in the face. We're going to say rainbowed out. You're rainbowed out with all the A, H, and K. Where does A, H, and K fall into the square root function? This is how the skeleton looks. A square root x minus h, and notice the h is under the radical, plus k is equal to our function. So a is the coefficient in front of the square root. H is what's added and subtracted under the square root, and k is the number, the constant that's outside of the radical. Now, we've talked about what A, H, and K do. Okay, A, it makes the graph either go over and be the rainbow, or if A is negative, let me draw this in a different color. If A is negative, it will reflect it under the axis. So instead of being a rainbow over, it will be a rainbow under. It reflects it over the axis. So that's the first thing that A does. The second thing that A does is it also will stretch it taller or compress it to the axis. Okay, so if A is greater than 1, so if A is 2, 3, 4, it's going to stretch it away and make it taller. It will pull it away from the axis and stretch it. If A is less than 1, so if A, and we're talking about the absolute value here, absolute value is less than 1, it will compress it. It will compress it. It will make it smaller. So I'll draw this one in pink. Okay, so this one's going to be my pink graph. It's going to pull it closer or compress it towards the axis. So the blue line, the blue graph is my parent function. Okay, the red graph is when A is greater than 1, it stretches it taller. When A is less than 1, it compresses it closer to the axis. Okay, so let's look at an example. What if A is positive 3 square root of x? Okay, A is 3. It's going to go with the top graph, isn't it? It's going to make it taller. What if A is 1/3 the square root of x? Well, that 1/3 is less than 1, so that means it's going to be the pink line. It's going to compress it and pull it closer to the axis. Okay, what if A is negative, let's say 5 square root of x? What's going to happen now? Well, it's going to grow it taller. It's going to stretch it up, but it's also going to reflect it, isn't it? So what is it going to look like reflected? It will reflect over the x-axis, not the y-axis. It reflects over the x-axis, and it will be way stretched away from the x-axis. So that's what a negative 5 square root of x would look like. So that's how A affects our square root function. Now let's look at H and K. And by now you guys should be experts at the AH and Ks. Okay, H and K. H is our horizontal shift, right? Horizontal shift left and right. It changes my X value. K is my kangaroo. Okay, it's my up-down shift. So if I start my parent function at 0, 0, and we're going to keep A1 for this example, I'm going to have the square root of x minus 3 minus 2. The first thing you want to do is identify H, my horizontal shift, and K. In this example, H is, it says x minus 3, and we always say the opposite of H and the same as K. So that means my H is positive 3. My K is negative 2. So I'm going to have a horizontal shift of positive 3. That means I'm going to come to the right 3, and I'm going to have my K go down 2. So my new origin, what was at the origin, is now shifting to the ordered pair 3, negative 2. So my new starting point is now at 3, negative 2. So here is the new starting point for my rainbow. 3, 2. Over 3 down 2. Now, my curve, since A is a 1, I still keep the curve at the same angle. It doesn't stretch and it doesn't compress. It's going to stay at the same angle. So notice I just took the same angle and drew it over there. So that is what H and K do to my graph. Okay? So far so good. That's an overview of A, H, and K and its effect on a rainbow function. Now, before we move forward, I'm going to show you one quick example of a negative 2 square root of x plus 4. My A is negative 2. My H, there is none. My K is positive 4. So my HK point is 0 because 0 is H. My K is 4. That means my starting point is at 0, 4. So it's going to slide up 4. My reflection is going to go down because this is negative and it's stretched away a little bit. So here is my new graph, my general graph of negative square root of x plus 4. There we go. There's your first example.